Okay, today we're going to talk about addition and subtraction of polynomials. Let's start off with an example. 3x squared plus 7 plus x plus 14x cubed plus 2 plus x squared minus x. Well, let's see, what do we do here? First, what we want to do, let's drop all parentheses, okay? We see a sign outside of here, which is this plus. We're going to distribute that plus sign to every single sign inside of this parentheses, okay? So that means every sign is in this parentheses is going to get multiplied by a positive. Well, if you think a little bit, if we multiply it times a positive, it's actually going to stay the same, because a positive, we multiply it times a positive, we're going to end up with a positive. Now, if we take a positive, multiply it times a negative sign from up here, we're going to end up with a negative. So if we're multiplying by a positive, all signs stay the same. And as you'll see when we get to subtracting, when you multiply by a negative, all signs switch to the opposite. Okay? Well, after we distribute this, now we don't want to turn this into multiplication, because what a lot of students will do, they'll distribute this plus sign and then they'll just do this here. They'll do this. And they won't put any symbol in between there. And then they'll turn this addition problem into multiplication and start distributing. That is wrong. This is the wrong way. That is the wrong way to go. Okay? I'm going to show you exactly how we do it. All right. So let's get this out of here, just so you guys can make sure you don't make that mistake. Let's go ahead and erase that there. Now, what actually happens is once we distribute this positive sign, all parentheses are going to drop. So that parentheses is going to go, this parentheses is gone, that parentheses is gone, this parentheses is gone. And then we'll have 3x squared plus 7 plus x plus 14x cubed plus 2 plus x squared minus x. Okay? Now, we can add this horizontally or we can add this vertically. Now, vertically is more of a simpler way to add this. Let's go ahead and just use the horizontal method, because we're advanced students, so we know how to add like terms, of course. So, like terms, of course, would have the same variable and the same power. So, let's look. Do we have any powers with any other powers of 3 besides 14x cubed? Because let's just go ahead and start with the largest power, so we'll be in standard form already. Well, no, it doesn't. So let's go ahead and bring down 14x cubed. And we're done with him. Now, the reason we're done with him is because we don't have any other powers of 3. Okay? Now that we have our power of 3 gone, let's look at powers of 2. Well, we have this is a power of 2. We have this is a power of 2. Do we have any other powers of 2? No, we don't. And these do have the same variables. They're both x's. Okay, so let's add this. Now remember, this will be a 1 in front of this x squared here. So it'll be 3x squared plus 1x squared, which will give me a plus 4x squared. Okay, and I'm done with that, and I'm done with that. Now, let's go down to our first degree powers. Okay, well, let's look. We have a positive x here, and we have a negative x here. Well, a positive, negative, those are just going to cancel out, because of x minus x will give me a 0, which would basically mean they're canceling out. Okay? Now, let's move to our 0 degree powers. Our 0 powers, which are constant terms. This here, and this 7 here, and this 2 here. Well, 7 plus 2, that's a positive 9. We're done with that, and we're done with that. Now, as you can see, since we're left with a constant term here, since we just did added our constant term, we have no more terms left. So this would be the sum of this polynomial here. Okay? And that's how you would start off by adding polynomials. All right? Let's go to another example here. Let's go to another example. Let's say we have 1 minus x squared minus 3x squared plus 2x minus 5. Now, as you can see, this is not an addition problem. This is a subtraction problem. Now, what did I say we do? Anytime we have this sign, what we do, we take this sign and we distribute it to every sign inside of these parentheses. Perfect. So now this, don't take all the signs as that they're going to stay the same. Because what happens when we multiply by a negative, the sign switches to the opposite. So of course you know that it's a positive sign here. So what we basically are doing, we're saying a negative times a positive, which will give me a negative. Then a negative times this positive here will also give me a negative. But then this negative times this negative, that'll give me a negative times a negative, which will give me a positive. Now, if you can recognize the pattern here, we see that if it's a positive, it's going to be a negative. And if it's a negative, it's going to be a positive. Okay, so what that means here is that anytime you're multiplying anytime you're distributing a negative sign, all the signs are changing to the opposite. Okay, so let's do that. We'll have 1 minus x squared, because remember, after we distribute this, all parentheses drop. So we have 1 minus x squared. Now remember, this is a minus 3x squared because I distribute this negative sign. And then this would be a minus 2x because I distribute that negative sign. And then a positive 5 because I distribute my negative sign. Perfect. Where do I go from here? Well, let's start off with our highest power, and it looks like our highest power is 2. So we have a minus x squared minus 3x squared. Okay? Well, what will this give us? This will give us a minus 4x squared. Right? Because it's assumed that there's a negative 1 coefficient here. So we'll get a minus 4x squared. Okay? Now that we're done with our x squared terms, let's go down to our first degree terms, our first power terms. Well, we have a minus 2x. Is there any other x term here? Well, no, there's not. So we'll just bring down this minus 2x. Minus 2x. And we're done with him. Now, we have a positive 1 and we have a positive 5. Now, what do we do with these? 5 plus 1, of course, is a positive 6. And that is the sum of this here polynomial. All right? Now, this is actually a binomial subtracted from a, this is a polynomial subtracted from a binomial, okay? Same idea when we're dealing with polynomials subtracted from polynomials. And we'll do one more example of that, and then we'll conclude this video. Okay? Let's erase this here. If you guys didn't get that, just go back and pause the video. So, let's start off with this here. We have a minus 36x squared. And then we have a plus 6x. And then minus 11. And it says we are going to do what? Well, we're going to... let's go ahead and add it. Let's go ahead and add this here. Let's add it to 6x squared plus 16x cubed minus 5. Well, we distribute this sign to every sign in here. And of course, since it's a positive, all these signs will stay the same. So I have a minus 36x squared plus 6x minus 11 plus 6x squared plus 16x cubed, and then a minus 5. Okay, because all signs will stay the same in this second polynomial because I'm distributing a positive sign. All right. Now let's start off with our highest degrees, and let's see exactly how this sum will come out. Well, this looks like it's my highest degree. So is there any other number or monomial that has an x variable and that has a power of 3? Well, no, there's not. So this will be 16x cubed. And we are done with that monomial. Now, let's go down to our second degree powers. Our second powers. Let's see. We have minus 36x squared, and we have a plus 6x squared. Okay, well, let's go ahead and see what we can do with this. Well, minus 36x squared plus a 6x squared. This is different signs, meaning we're going to subtract. Okay, so we have a minus 36 plus 6, and we should get a what? A minus 30, because of course you know it takes a sign of the number with the largest absolute value. So this is minus 30x squared. Okay, so that's minus 30x squared. So we're done with this and we're done with that. Now let's go down to our first degree powers, which are 6x here, and looks like that's it. So we'll just bring down that plus 6x. Cross it out. Now, our 0 degree powers, which are our constants here. Let's take it. Minus 11 plus 5. Minus 11 minus 5. Okay, minus 11 minus 5. Well, this means we're going to add, and we're going to get a minus 16. Okay, a minus 16. And looks like we're done. We've taken care of all of our numbers, and this is the sum of this here polynomial. These here polynomials added. Now, just to keep everything fair, I'm going to do one more subtraction problem because I've done 2 additions, so I'm going to do one more subtraction. So let's go ahead and get to that. Okay, let's take here 5x cubed plus 12 plus 6x squared minus 15x squared plus 3x minus 2. Okay? Well, let's start off by, of course, distributing. Let me write that over again. Let's start off, of course, first by distributing this negative sign. Now, of course, you know when you distribute a negative sign, all signs change to the opposite. So this is a positive here, so that means it'll be a negative here. Well, we'll do that as soon as we write this here out. So let's go ahead and take it. We have, now this is a 5, not a 15. So let's go ahead and take out these parentheses now that we've distributed those signs. We have a 5x cubed plus 12 plus 6x squared. Now this is going to be a minus 15x squared because we distribute that minus sign to a positive sign. And then this is a positive sign, so it'll change to a minus 3x. And then this is a minus, so it'll change to a positive 2. Now let's go ahead and add these here. Well, let's see. We start off with the highest power, which it looks like is 5x cubed. Do we have any other x cubed powers? No, we don't. So 5x cubed, and we're done with that. Now, let's see, do we have any squares? Yes, we do. We have 6x squared, and we have a minus 15x squared. Well, 6x squared minus 15x squared, what is that? What would that give us? Well, it'll give us a negative 9x squared, and we're done with that, and we're done with that. Now, let's go to our powers of 1. Only one that looks like we have is a negative 3x. So let's go ahead and just bring down negative 3x here. And we're done with that. Now our 0 degree powers, our 0 powers, which are 12 and 2. 12 plus 2 would give me 14. Okay? And this is the sum of this this is the difference of these two polynomials here.